Good day all, welcome to another video of mine. We're looking at a question under commutation. Now question says a 4-pole lap wound armature running at 1500 RPM delivers a current of 150 ampere and has 64 commutator segments. The brush spans 1.2 segments and inductance of each armature coil is 0.05 millihenry. Calculate the value of reactance voltage assuming is 1. Linear commutation and 2. Sinusoidal commutation. Neglect mica thickness. Now we are told what wave wound. That means our A is what number of pole, which is 4. Which is what 4. Okay. Now the value, the action is to calculate the value of our what reactance voltage. So our reactance voltage is giving us L times 2I. That's if we are assuming it is what linear commutation over CC times your A. Our L is given, our I is given, our A we know, so we need to get our TC. So our TC is giving us WB, where your WB is the width of your brush, and that of your WM is your mica insulation width. Now all over your peripheral what velocity. In this case we weren't giving our width in centimeter but in what segments. So that of our brush hole is what is 0.2 segments. So let us find our peripheral voltage and velocity in segments per what seconds. So doing that, we convert this value to our value of that in what ROPS. That will be 15/60. Doing this with a calculator, we have our answer is what 25 ROPS. Now for us to get our answer in segments per seconds, we'll be multiplying this 25 by the total number of what segments, which is what 64. So we have that V is equal to 64 times 25, and we have that our answer is what 1600 in what segments per seconds. Now we have gotten our V. We are now going to impute our value here to get our TC. So our WB is what? 1.2 all over. Our V we have is 1000 watts, 600, 16. Now in calculator you impute 1.2 divided by 16, and you have that your answer is approximately, okay, is in fact 0.75 milliseconds. 0.75 milliseconds. So that's the value of our TC. Now we'll be imputing that value in our formula to get our reactance voltage. So we have our L to be what? 0.05. We have our times 2. We have our I to be what? 150 over CC being what? 0.75 times 10 raised to power minus 3 times our A, which is what? 4. Now imputing this in the calculator, okay, I swear I forgot a particular thing. This was expressed in 0.5 milli. I didn't add that, so we'll be changing this to 0.05 times times 10 raised to power minus 3 because of our words milli. Okay, now imputing our values, we have 0.05 times 10 raised to power minus 3 times 2 times 150 over 0.75 times 10 raised to power minus 3 times 4. And we have that our answer is what? 5 volts. This is for what? Linear commutation. That's for our I. Now for our II, assuming that is what? Sinusoidal commutation, our reactance voltage is giving us 1.11 times your L times 2I over TCA. Now this value we have gotten it already, so we'll simply be multiplying 1.11 to our 5. So this is our answer for sinusoidal what? Commutation. And now I would like to say before I conclude is that in case where you don't see, maybe you might be asking that this 10 raised to power minus 3, I'm only adding it there for the sake of clarity. Our time was also in milliseconds, and our inductance was also in millihenry. So this can actually cancel out. And I mean, if you're not going to put this, you shouldn't also put this on top. So, but still, you can still leave it like that for clarity's sake. But if you don't put it, know that what is cancelling out is that of your CC, it's cancelling that of your what? Inductance, your L, your microhenry. Okay, so that's all for this video. Please subscribe to the channel and click the notification icon to receive updates. Thank you and God bless you. See you in the next video.